So what we're going to be doing in the next section is quantum error correction and quantum error correcting codes and a bunch of other stuff. So what I'd like to do is I'd like to start with a little overview of classical error correcting codes. And because quantum error correcting codes are just classical error correcting codes quantumized. Just like, well, kind of like the quantum Fourier transform was a discrete Fourier transform quantumized. So I want to talk about errors. So suppose I have a, well, we call, in information theory, they're called messages. But they might be a movie, or they might be a song, or they might be something else. And you have a DVD player, and if you take a DVD and you scratch it, you're destroying some of the bits on it. But then you take this DVD player and you DVD and you stick it in your DVD player. Miraculously, despite the fact that you've destroyed a bunch of the bits on it, it still works. Unless you scratch it a lot, in which case it stops working. But that's because the DVD is encoded with a classical error correcting code, and it makes, and it corrects errors. So I'll start with I think I want to start with a first error correcting code that exists. But first I'll tell you a little story. So in the 19th century, ships went around with chronometers. And the reason they all had chronometers, and these were very important, is you have a globe here. And you can, if you can figure out your latitude by looking at the stars and seeing, well, you can see how far from the horizon the North Pole is. But how do you figure out longitude? Yeah?
Compare local time to a constant time reference?
Well, so you know when the sun is supposed to rise at your latitude, and that's local time. So compare sunrise with clock. But you need a really, 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 really good clock to do this, because if you're off on a voyage and it takes months and your clock loses or gains several minutes, then you really are not sure where you are in terms of this. So, as I say, you need a very good clock. So there's this book called Longitude by Dana Sobel that tells about how this one man, so the British government put out a prize of some huge number of pounds back in those days for constructing a way of determining longitude. And this guy spent his entire life developing an accurate chronometer, and I'm trying to, I don't know if, and it took him an enormous struggle to get the money, and actually the chronometers that ended up being used were developed by some guy in France that used some of this guy's ideas and some of their own ideas and developed accurate chronometers, which by 1800, I think that's 50 years after I've forgotten his name, lived, they started putting them on ships. But a ship always carried 3 chronometers. Can you tell me why? So why don't you just carry 1 chronometer? Yeah?
One of them's faulty, you can sort of take the majority of
Yeah, if you have 3, If you have two, and one of them says 8:35 and the other says 8:55, you don't know which one's right. If you have three, you can take the majority. You don't really want to average them, because if one of them says 8:55 and the other two say 8:35, you know which one's right. So that is really an error correcting code.